I think we're shortly ready to start, so I would just love to welcome everyone who is here today, who is joining us from the stream as well. And today we'll be talking about introduction to IPFS and Filecoin and how they shape the future of Web3. There'll be multiple topics we're covering during the session, so at the end of it, I will also give some time to answer all the questions, so feel free to stay tuned, and we'll be here also during the hackathon, so let us know about all your questions and ideas about building projects during the hack. To start with, there are multiple projects which we have inside the Protocol Labs. Myself, I'm a startup operator at Protocol Labs, but we work as a community of people and organizations that are building better future through the technology. There is Protocol Labs, which is open source R&D organization. There is a Filecoin Foundation, which is a steward of Filecoin community, which is aspiring to put the power of humanity, most important information, back into the hands of everyone. And there are also multiple core solutions such as IPFS, which is a peer-to-peer protocol that making web upgradable, resilient, and more open. You can think of it as a peer-to-peer version of an HTTP. And there is a Filecoin, which is a decentralized storage network to store humanity's most important information. You can also think about it as an Airbnb for storage. And those are multiple components which come together in one place to be the Web3 layer foundation for the data storage and much, much more. So we'll go through an agenda today, which first will be the core concepts of IPFS and Filecoin. Then I will tell you more about the tools of Web3, which will be particularly handy for you during the hackathon to build straight away on top of IPFS and Filecoin. I'll also highlight you the possibilities of Web3 right now to give you a bit more ideas of what is possible, what could be done, and maybe that will be helpful for some of you to brainstorm your ideas further. And there will be also some learning resources and discussion Q&A in the end. So, starting with the concepts of IPFS and Filecoin, I will not go into too much details what exactly Web3 is, but trust me that we are on somewhere transitioning from Web2 to Web3, where Web2 was read and write, so you could write an information on the internet and you can read it from. And now we're transferring to Web3, which is read, write, and trust. And trust here is being an operative thing where you can verify some information on the internet directly without having a prior knowledge to it. It's also being supported by a bunch of underlying primitives and technology that builds up to verifiability directly in Web3. Moreover, Web3 stack is for Web3 stack, verifiable data is essential for a truly distributed system. This image is already quite outdated, but because the Web3 is exploding like hell and there are more and more projects appearing each and every second. But at the same time, the file storage is still a core fundamental piece of it. Moreover, you can place now us not only in file storage as it is with IPFS and Filecoin, but you can also definitely move us to the cold storage solutions, and with soon updates of the Filecoin, where we're developing smart contracts and Filecoin virtual machine, you could also easily place us to the layer 1 blockchains with smart logic and smart contracts. So once again, we are somewhere in transition between Web 2 and Web 3, where Web 2 is being decentralized solution, where the data, knowledge, and information is being kept at the centralized points, and we barely have the ownership of that data, which is being centralized. It's a critical point to the human development, and that's why we at Protocol Labs believe that this distribution of the knowledge and distribution of the power should be safeguarded, and that knowledge should be open and in the hands of people. But at the moment, data, information, knowledge is not publicly open and publicly owned, and there are a few companies which you're familiar, which is Google, Amazon, Apple, which are being the silos of the data and limiting the ownership of that. And if some of this solution fails, due to the system being centralized, it fails altogether, and you basically lose access to your knowledge. What you can do instead of having a centralized solution where you have single points of failure where your data is monetized by the data monoliths, you can have a decentralized or even better distributed system where the users have the power to manage their data, where the users power the service themselves, and at the same time, the infrastructure which is being developed in a peer-to-peer manner, it's also being censorship resistant. It ensures the privacy of your data. You can self-verify all the content which you're having in the web, and the data is being non-siloed, meaning that at any point of time you can discover the information that you're really interested in without any limitations. And I will tell you in the next 15 minutes, or in the next half an hour, what is IPFS and Filecoin and how they contribute to this vision of distributed, decentralized Web3 internet, and how to build on top of those protocols to make sure that you're really going to the future in the Web3. And moreover, I will tell you that files and folders is not a boring thing. So first of all, IPFS is an interplanetary file system, where files and systems is file system is obviously files and folders. You are familiar with them already. You work with computers all the time, so there's just the same thing. While interplanetary thing is way, way more interesting. Imagine that you have to send. Imagine at some point we reach Mars and we'll have to send information from Mars to Earth. If we maintain these centralized solutions for any call or any update or to watch a video, you'll have to make a call from Mars to Earth and from Earth to Mars backwards. And this will at least for one call take you an hour. So that's not very scalable solution when you think about expanding to other planets or generally just expanding your network. And that's where IPFS is coming handy into the place. Because of distributed solution in the first place, it allows you to download the files not from the central place somewhere on Earth, but rather have, if someone has it already cached on the Mars, you can directly retrieve it from them, therefore connecting and creating a network of peer-to-peer data exchange where everyone can cache and store the data, and it's available not from only one source but from multiple sources, creating this resilient and distributed solution that can scale across the planets. And that's where resilient and offline-first solutions such as IPFS is coming very, very handy to develop a network which is independent of centralized solutions. Moreover, in order to achieve so, it's very, very complex if you try to address the data as you commonly do it in Web 2. For example, if you're looking for a book and your friend tells you, oh, you can find this book in the library, on the second floor, on the third bookshelf, and on the third row from the top, then and it will be the second book from the right. When you come to this place and get the book, suddenly you realize that it's the same book which was in your backpack, but you just didn't know that it was there, and you didn't know that you were referring to this book. Exactly the same thing is happening right now with computers or Web 2 way of addressing information, where in order to find a file, you actually go to the location of it. Instead of that, or it's actually happening the same in the browser, where to find an object in the internet, you go to an HTTP domain, you go to the path, to the index of it, and then you find a file there. It's a very, very weird way to structure finding information, and why not instead to actually look for information itself? So instead of going to the library to a certain place, you just tell a person which book to find, and essentially you are looking for a content and not for the address where it's located. And that's where IPFS brings the most value, because it allows you to address the content by what it is instead of where it is. You essentially replace a folder or a file location with a content ID, which is a unique fingerprint which allows you to discover the object's internet regardless of their location. And I will tell you more how the IPFS works specifically. For example, you have a content which is hello world text document. And you create a cryptographic hash function out of it, which is a SHA-256 standard algorithm, and you create a content identifier for that. So once you created a content identifier, this is a unique fingerprint which points to exact content of the file which you created. So the same content will always resolve in the same CID, and content CID can be reproduced anytime from the original content. So imagine that it's independent of who creates the CID, rather it's always a computer which is dependent on the file you upload. So if you have the same content, any computer in the world or any solution will create you the same CID, therefore you can easily discover the object by what it is rather than by where it is. And it also adds us this trust function of the Web3, where once you received an object from the IPFS or from any other solution, you can validate through the CID if the content you received matching the original CID you requested. If something is flawed, then you'll have a different CID, and then you know that it's not the content you were looking for. The best part of it is that content is not only files itself. Folders could be the same content, and essentially a folder is a special kind of a file which lists other files inside of it. So all the core principles which apply to the files in IPFS work the same way in the folder structure, so you can also use files and folders in IPFS without any limitations. And to give you a brief idea of how exactly it works, here's a small diagram where we have 4 objects in the bottom, and each of it has produced its unique CID, so you can always trace an object by a CID. And these images are grouped into 2 folders. First one containing the first 3, and you see by different colors there is a fingerprint, so these are different CIDs in the, on the first place. Then all these 2 folders are then connected in one folder, and you get the root CID of the first initial folder. So when you have the root CID, you can discover which objects and files are inside of it, and which CIDs continuously are inside of it. And that's what exactly Merkle DAG is, or Merkle Direct Acrylic Graph, which is a graph's data structure, and where each node is content addressed by itself. So CIDs and IPFS allows you to not only address the files, but also the structures in the direct acrylic graphs. And the beauty of it, it allows you to really deduplicate the internet in a sense that, imagine there is a case where a new folder is created, but the content of this folder is based on already existing solutions in IPFS and on already uploaded content. So here, for example, I create a new folder which contains 2 write images, and even though I create a new folder with a new list, apparently it gives me the CIDs of the previously added objects because, again, CIDs are referring to the object content and not to the where they are located. Therefore, we get the ability to duplicate the amount of files we store, and essentially instead of storing hundreds and thousands of memes on the internet, you can just store 5 redundantly and always point to the same objects instead of just storing them again and again and again. This also gives us the verifiability. If some of the contents inside the folders change, then a new CID will be as a result, and therefore you can always trace whether the data which is served to you is reliably what you have requested. In order for this to work in the network, in a peer-to-peer network, there is also some functionalities which needed for you to have as a network. So first of all, the network of IPFS is a swarm of peers, where peer is a node in a peer-to-peer system. In order for the system to work, there are many, many peers across the world which are serving parts of the content. Therefore, if something changes or something happens to any of the peers, this whole system still became resilient, and you can just retrace the content or find the content on any other peer that is available and still online. So in order for the system to work, you need to impose several requirements on the peer-to-peer system. Therefore, each and every node in the network must be discoverable, so you have to be able to discover where the node is located and which content it contains, and it must be routable, so you need to be able to any node to have a trace through other peer-to-peer nodes, so that at any point of time you can discover both the content and where it is located. And that's where a distributed hash table functionality, which is available in IPFS, is coming very handy. Imagine distributed hash table as something like a phone book, where you have a name of a person and a phone number of a person. But instead of having just a phone book by yourself, you are sharing it with your friends or your peers, so you maintain it jointly, and you all adding new names and new numbers to it. And that's exactly how the distributed hash table works in IPFS. So there is a group of peers or a group of nodes which are maintaining this same distributed hash table and adding the content to it upon uploading to a specific peer or node. And it's maintained by multiple peers, but only a small number of peers, so you never have a distributed hash table of the whole IPFS because it will be a tremendous size and very hard to maintain. Rather, if the content is not served in this particular DHT or distributed hash table, the peer itself can refer and ask neighborhood peers if they have content in their DHT tables. And it's very fast and very simple to trace whether there is a content available on IPFS node network in general and in which particular DHT table it is located. Because all the DHTs contain the CIDs of the content in a manner that they are discoverable and in a manner that they are grouped together by similarity of the CAD compared to the content. And that's where it's becoming really easy to manage and operate the whole network, because every peer can add rows to the DHT table, declare their peer ID, and provide specific CADs based on how they connect to the peer ID and how they're available through the network. Moreover, peers can query the DHT to find peer ID, which is providing the which content ID, so making every node available to trace and reach any content in the internet, and that being a self-served system where it's also independent of protocol apps or development solutions, where you can, it's an open protocol on the first place, so whenever you have this solution, it's available for you at any point of time, regardless of limitations or centralization, which I talked to you beforehand. The very nice piece about it is that once you have all these concepts ready and technically working, which they are already for quite some years, you need to start think how to build a network out of that and how to serve the content which you particularly have or you own through the network, so it's available to you over time and it's available to you whenever you need it. So there are multiple ways of using IPFS in general. Though you need to understand that if there is no nodes, there is no retrievability. So you need to think about who actually runs the nodes in peer-to-peer network. So obviously, first of all, you can run your own node and store all your content just on it. But then it's becoming the same single point of failure, and if something happens with your content, then it's basically lost. Then you can also run your own network of nodes, but at the same time, it comes at the cost of infrastructure running and the team to manage it. You can also pay pinning services that are available already right now on the network, such as Pinata, Temporal, Infura, and many more. But this is a payment solution, so you have to pay someone in order for them to provide you the content from peer-to-peer network. And at the same time, you may just hope that content becomes popular enough and that that other nodes will pin it instead of on your behalf just for free. And does that system where you have to rely on a solution or on someone's goodwill to pin your data in order to be able to retrieve it sounds reliable and decentralized for you? For me personally, not. And that's exactly where we can talk about Filecoin and how Filecoin incentivizes persistence and verifiability of storage on Web3. Filecoin is a solution which allows you to make a deal with a storage provider, which we have more than 4,000 at the moment, with more than 18 exabytes of storage capacity already available on the network. And it allows you to create a deal where a storage provider confirms that he has your data for the duration of the deal, and at the same time, it's available and we can verifiably prove that he stores your data continuously through the whole duration of the deal. The duration of the deal, and the provider has to run cryptographic proofs on the data which he stores for you every 24 hours, so we're making 100% sure that the data is available. And the beauty of it is that it's also being replicated multiple times or stored redundantly on the network, so that even if something happens with one single storage provider, it's always available to you regardless of what. An additional benefit, or the way we designed it to actually serve the multi-purpose, is that it also utilizes the same CAD solutions as I just described you inside of the IPFS. So essentially, you can have your IPFS CAD being stored and verified over a Filecoin deal, and it's stored redundantly multiple times. So that's how you achieve this decentralized verifiability storage on Web3 for your lifetime of your project, your lifetime of solution, and just long-term preserving your knowledge, which is essential for human development. And that's where you can also run multiple times the dealing on the Filecoin. That's where you first receive the fundamental reliability or resilience of the structure. The beauty of it that you can also run it in parallel with cloud or with any other solution, because we are essentially agnostic to what are the other solutions you are using to store the data. You can also back up it with the cloud. You can use different solutions from different storage providers, but it doesn't stop you, or we do not lock you specifically on Filecoin for you to retrieve your data. And that's where I would say that IPFS is really loving Filecoin, and they really designed to work well together, where IPFS is designed for the fast and flexible retrieval, where the gateway is local local nodes and browsers are available. The beauty is that right now we are also natively supported by multiple browsers. The Brave is already fully supporting it and running an own IPFS node on the background for you, so you can directly watch in the browser all the content from IPFS. And there are multiple more browsers that are coming soon with the implementation of IPFS reading, whether they're using just a gateway through IPFS or they're directly installing the nodes. The more are coming from Firefox, and then we're also working on implementing it into the Chromium, so all Chromium-based devices will be also natively able to read IPFS CADs and content inside of it. Also, on top of the IPFS, there is a Filecoin, which provides you this needed persistence and verifiability of the data on chain and reliable storage of the data for the duration of your content or duration of the lifetime of the deal which you have made on top of IPFS and Filecoin. And that's where we can slowly transition to the tools of Web3, where you can, I will give you in the next 10 minutes the details how you can build on top of IPFS and Filecoin, and how to easily kickstart your project during this hackathon so that there is no problems in building your own nodes and finding the solution that you need to develop on top of IPFS and Filecoin. So the very first and very, very easy to use solution is NFT.storage, where it's a completely free solution to store your NFTs with simply two lines of code. You can register on the NFT.storage website, you can get your API keys, and whenever you make a call with an API, your data will be stored on IPFS and Filecoin, and it will be pinned redundantly 5 times across the network. The beauty of it that CADs are again computed locally, so there is no dependency on any of the storage solutions which you are using, and at the same time you can still discover it over the traditional IPFS network, so all the content could be stored and served on the web directly through NFT.storage. Also, the beauty of it is that from Protocol Labs' perspective, we are treating NFT.storage as a public good, therefore it's designed to be completely free for use for any NFTs. We preserve the NFTs as a common knowledge, and we believe that that's the way how to build the Web3 so that people really have the access to the data they create at any point of time. Also, if you even think about, but what's the incurring cost? Maybe we'll run it for price later on and then charge everyone because they are locked to the system. Apparently, we are also at least 100 times cheaper than AVS and cloud solutions, so it's run on behalf of Protocol Labs, and whatever happens to the solution, it still could be pinned on your local nodes and be available and retrievable at any point of time. When you want to scale your solution not just for NFTs, but for any kind of storage, that's where the Web3.storage is coming the most handy. It's a solution for general IPFS and Filecoin storage, and it provides you a simple and familiar interface, also with only 2 lines of code to implement to store it reliably on IPFS and Filecoin. And it provides you 1 terabyte of data for free, so you can use very simple JavaScript or Go client implementations, and it has an HTTP API for remote pinning service and a web interface to upload your data or to retrieve your data on your browsing solutions. When you're also thinking about developing your websites, that's where Flick hosting is coming into place. It's flick.co, and it allows you to build your websites on top of IPFS and Filecoin and store them directly into a IPFS network, which makes you independent of any cloud storage provider, and it's reliably accessible through the peer-to-peer network as well. It is very easily built on top of GitHub repository, so you can just connect it, set up your build settings, and it will be deployed directly onto a IPFS and backed with the Filecoin solution. So just a simple and amazing tool to run your solutions on top of a really decentralized network and be ready for Web3 whenever you're building your project. There's also an advanced solutions or additional solutions where developers who have PowerGate, if they want to have a powerful ways to connect and extend protocols such as IPFS, Filecoin, and libp2p, it provides you the opportunity to have a Docker container wrapped around IPFS node and Filecoin node, and it gives you the flexibility of staging, storing, and retrieving data, and have the default configuration for the miner selection. And one more topic which I want to cover in this presentation, and which is the more and more upcoming and important effort of Filecoin in particular, is Filecoin Filecoin Green. It provides you now the opportunity to measure the energy which is used by storing your data, and our whole effort of Protocol Labs and IPFS and Filecoin in particular is to build the reliability on the web, where you can specifically verify that the data is being stored in a sustainable way, and it's provable that the sustainability aspect is not faked or is not just a number on the dashboard, but rather it's something which is cryptographically or verifiably proved that the solution is totally green. It also provides you the consensus mechanism that is used by Filecoin, which requires each node to prove that the resources it contributes to the network. Therefore, you can easily calculate the amount of the energy which is being used to store your data, and then later on scale it to more projects on the green aspect of the sustainability of the blockchain. I think that is one of the interesting topics to work also on in the scope of the hackathons, because the green aspect was not that in the radars of developers for quite some time right now, but we are seeing more and more the problems or the general sustainability issues on the world around. And I think, as Vitalik was mentioned, it's really a matter and great effort to build the sustainability of the blockchains in the first place, making sure that the tools which we're building are scalable to the future, also from the sustainable perspective. And that's where I'm coming to the amazing possibilities of Web3, or what to build right now, how to build it. And generally, it's an amazing network which we are running, and the ecosystem which accounts for many, many people building on top of IPFS and Filecoin. It's quite an outdated view already, but there are all types of solutions, from Flick, from Orbit, from technical solutions. There are also many, many teams that are building on top of IPFS and Filecoin from other chains. There are practical technical implementations, and I encourage you to look through the hackathons.filecoin.io website, where most of the hackathon participants from the past year were listing their prize projects. So you have all the access and all the knowledge which we maintain across our ecosystem, so you can have your kickoff of the project for the hackathon for ETHAmsterdam as soon as possible, and build on top of reliable solutions rather than developing something new from scratch. Also, there is a list of projects I really like in particular, which were using IPFS and Filecoin. First of all, we are also backing up the Internet Archive, which contains the most important human data right now. We are also collaborating with Starling Lab, which creates a framework for data integrity and preserves testimonials of the Holocaust survivors. That's where we're also looking to contribute to the public goods and Creative Commons. They're an effort joined together with Ethereum Foundation and Ethereum Networks, where we're collaborating on funding retroactive public goods funding, and generally finding solution for the public goods to be reliable and accessible topic over the Web3 as well. There are also nice practical applications such as Audios, which is a new version of music tool where you can listen to music, podcasts, and everything. There is Live Peer solution, which gives you the opportunity to do video streaming and NFT minting of the videos straight away with their development. We also have an amazing projects with teams or organizations outside of the Web3. For example, we're developing the New York City open data with Filecoin and IPFS. And if you're familiar with OpenSea or Rarible, or you're generally interested with NFTs topic, then I can also highlight that in the backend of the OpenSea, they're also storing all the NFT content through IPFS and Filecoin. So in order to summarize that, Web3 is essentially a decentralized web where the blockchain is a fundamental layer which allows you to make verifiability on-chain and provides you the independency of a centralized state, rather than ensuring that the content is being available, is being linked, and being resilient to the future-proof solutions and applications. And just to sum it up, apparently the best way to predict the future is to create it. So I really encourage you to do all the best on this hackathon, having an amazing 36 hours of hack. Build your projects, build it on top of IPFS and Filecoin. Let us know if you have any questions about how to build us. Will be available on the booth. We'll be also giving a talk tomorrow. Our CEO, Juan Beneth, will be providing a talk on public goods and crypto economics. So there is a lot of opportunities. And once you join the ecosystem, there are more than just building on top of IPFS and Filecoin. We are also running a huge grant program. So for us and for you, Hackathon is just the first step. You can scale further with our grant application, with our micro grants, development grants, and then launching further your project with pre-seed, seed rounding, and startup as a part of an awesome community. And last but not least, I will also highlight for you some learning resources. There are Discord and Slack available, and specifically for this hackathon, I believe we are running through the ETHGlobal Discord, but feel free also to join our Discord and Slack from IPFS and Filecoin. You can find it at filecoin.io/Slack, and you'll have all the answers there. We are working as a public company, so everything is available from our development directly on Slack. You can reach any of our team members on Slack, and that's where we believe that working open source is not only building open source solutions, but actually living open source, making sure that we are collaborating instead of hiding information, and where everyone can contribute to the scale of the greater good and a greater ecosystem. With that being said, I would just encourage and say good luck to you all on developing your hackathon projects. It's definitely an amazing time, and I was a hacker myself a few years ago. I love this time, and will be here together with my team to support all your questions and making sure that an experience for you to build on top of IPFS, Filecoin, and any other solution from Protocol Labs is an amazing experience, and you want to stay with our ecosystem further. Thank you a lot. And that would be it from my side. And I guess we are running greatly in time, so we have at least 10 minutes for the questions, but I'll also be happy to stay further and answer all your questions afterwards. So who wants to be the first? Yes, please.
Is there any solution for storing data in IPFS with like access control, or is everything always public? And if you had to do your own solution, is there any best practices on how to encrypt it?
Yeah, that's a very good question. Oh, yeah. So the question was if the content on the IPFS and Filecoin is public, or you can somehow encrypt the information first, or what are the solutions to work with the private data, essentially. So IPFS and Filecoin is deliberately an open network, so all your content which is stored through IPFS and Filecoin is public. You are completely right that you can first encrypt the information and then decrypt it when you download it, but it will still be available on the public network as a peer-to-peer storage solution. I would say that there are some teams who are working on encrypting the solution, on encrypting protocols on top of IPFS and Filecoin, but you are more than welcome to develop your own. I think that's a hot topic right now, and if you're working with some private data, it's very interesting to also think which parts of data is actually sensitive and should be private, because quite often it's only a small fraction of the actual content you want to store which is private, and you can split it and still store most of the content in a completely open system.
One thing to check out is maybe lit protocol. Lit protocol is common, I think, and they have some encryption stuff.
There was one more question. Yes, please. Well, whenever we speak about public goods, first of all, like foundational human knowledge is very important topic. I believe that the content about learning, about just general education is something which should be preserved and should be available regardless of the paywalls, regardless of proprietary information. That's something which all the society should build on top of. There's also public goods, which could be the data sets, which provides you the knowledge on, for example, medical data sets, or something which you can build on top of in order to create a more resilient and more efficiently working system. At the same time, public goods could be some I mean, there is common projects which we are building from retroactive public goods funding with Ethereum Foundation, where it's also being a focus of ensuring that the developments which are happening in the public goods field is being well funded and receiving sufficient support from the teams. And at the same time, apparently just storing the data for someone could be already a public good whenever the information which is being stored is socially valuable or just generally valuable as a human knowledge. Does that answer your question?
Yeah.
Thank you. Are there any other questions? Yes. So if we are speaking about web applications like hosting the website through Flick.co, I believe they're also hosting it on their own nodes, so you get quite good retrieval speeds. Though, yes, you have definitely keep in mind on the real retrieval speeds of the data. IPFS Filecoin is now not always as fast as the traditional solutions, though we are right now building the super hot CDN solutions where in 1-2 months it will be production scale ready and the same speed as the CDN of a traditional cloud. So that's the feature we are also aware of, and we are developing it towards making it large scale and available as a retrieval storage market. But that's a topic which we are also discovering right now. But there is already, like, you can already build on top of IPFS and Filecoin and get proper user experience, though it takes us an additional time to make sure it's all fluent and available.
And maybe to add to that, like for a specific use case, like NFT.storage, we're actually operating a retrieval node that's extremely fast already, which is like specifically for NFT.storage, just like address that problem. But yeah, there's more and more. But there's a couple of retrieval nodes that are actually extremely fast.
Yeah, I am talking about specifically like global coverage. But like where your node is, might affect, you might get good loading speeds around it, but
Yeah.
maybe for some users comes from the States,
Yeah.
then you need an additional node there.
Yeah.
And
I mean, Filecoin eventually will have, will incentivize that with the actual crypto economics, where you have a market for retrieval nodes, and then basically anybody could be a retrieval node, at which point you have an extremely atomized like CDN that's more distributed than any other CDN could ever be, right? Because anybody is a retrieval node.
Perfect.
So
Any other questions?
then what does it mean for me to run a IPFS node? Let's say if I want fast retrieval speeds, can I pin a content to my node?
Yeah, that's exactly how it works. So if you're, for example, if you're sitting in the same room and someone from the room already have your content, he can directly serve it to you instead of going to a centralized node and downloading and uploading it directly. So that's the beauty of it, where the more peers are serving the same content, the faster the retrieval you will get. And if you're working from the same network, that's the ideal case where the peer can just directly streamline you the content which he has. And that's where the more nodes, the better is the approach. But at the same time, having this retrievability speed is also dependent on like the size of content and some of the delays which may occur on like peer-to-peer networks, which are traditional to it.
But what is it internally? Is it object storage, or it's traditional Unix file storage? Or
Can you elaborate a little bit more on the question?
how exactly the file is stored inside the node? Is it like object storage, or do you use some technologies like, I don't know, how HDFS stores the files?
Yeah, so it's a file distribution. So it's any object could be uploaded independent of a file format, and it will be served from the node to the node. Not all the nodes will contain the file fully, so some of the nodes will be only serving it as like transmission nodes, so they do not need to store your file directly, but they'll be only transmitting through them, because essentially there is connectivity could happen through each and every node on the network. Any other questions? Yes, please.
I have a slightly more technical question. So as far as I understand, the way the CID hashing function works on images is that it divides the image up into separate chunks. And then
Yes.
it calculates a hash for each image chunk, and then the aggregate hash of all the hashes of the chunks of the image. What happens if I start downscaling my image? I start like pixelating it more and more.
Yeah, then the CID will change.
CID
Essentially, if you change any pixel of the content, you will always receive a different CAD.
But if the pixelation is so slight, the sort of decrease in pixel size maybe is ever so slight, that I'm not sure whether...
I think that's a very interesting corner case, and I would love to know if you explore that further during your hackathon. But I would assume that if the content or if the file size also changes, then it will also affect the final CAD, because essentially you store it in a different format than it was originally. So the idea of the CAD encryption is that every unique content creates its own unique CAD. And in downscaling, I believe you still change in the background of the file how it's been recorded. So it doesn't take your image directly, in a sense. It takes the way machine explains it and then transcodes it into a SHA function. Yeah.
Okay, interesting.
Any other questions? If not, I would love to thank you all for your attention. It was an amazing time. And
what's a good pinning service you recommend?
pinning service, I would use directly web3.storage or NFT.storage. They also pin the content on your behalf. So it will be pinned 5 times redundantly and available through the Filecoin deal for the Filecoin network. And it's also free to use. Yeah. Then thank you all and have an amazing hack.